Okay, we'll just start with the first example. Here we go. Complete the following. Solve for cos theta is equal to -5. All right. In grade 10, you would have done stuff like this. Go away. Well, that's why this is the review. This is a 1-minute review of grade 10. I don't know, 0.5. We'll just do that. If I gave you that in grade 10, how do you find the angle? You punch what into your calculator? Yeah. So you do this. Sine to the -1. Which is actually called, it's the inverse sine, which has a name, arc sine, but we're not going to go into that. All right. But that's the button you hit in your calculator. And what do you get? I don't even know. 30 degrees. There you go. Does everybody agree with that? What's 30 degrees in rads? Pi over 6. That would be the answer in radians. Okay. However, that's only half the answer in Math 12. Because what do we know about Math 12 or about angles in Math 12? Not much, yeah.
They're on like a grid?
They're on a grid, and if your sine theta is positive, that means sine is here and here, right? So that means this angle is 30 degrees. That angle is 30 degrees, correct? So what's the rotation to there? 150, right? Because it's 180 to here. So this is 150. So on your calculator, if you go sine of 150, you'll get 0.5. Okay? So you get two answers. Sometimes you'll get one answer. Sometimes you get two answers. Sometimes there'll be three. Sometimes there'll be four. Sometimes, as you will see later on, there are an infinite number of answers. That's your favorite word, isn't it? All right, so let's start at the beginning. Here we go. Cos theta equals -0.5, where theta is between 0 and 360 degrees. This is your domain restriction. It tells you what domain you're in. We are only doing between 0 and 360, so one rotation, okay? Every question is the same. So you draw a little grid. Cosine is negative. The negative tells you the quadrants you're in. Where is cosine negative? 2 and 3. Add sugar to coffee. So 2 and 3. Cosine is negative. Okay? So I know that we are there. Boom, boom. The next step is to find the reference angle. Okay? So to find the reference angle, you're going to do cosine to the -1 of, and this is really important, people, 0.5. You do not use the negative. The negative only tells you the quadrant you're in. Okay? Don't use the negative because it will give you false. It'll give you sometimes the right answer, but you usually will miss one. Okay? Sorry? It's 60 because it's cosine, not sine. So I'm going to get a reference angle of 60 degrees. No, we're going to do it in degrees because our answer isn't, they want it in degrees. So make sure your calculator's in degree mode. That's a good question, actually. So you should get 60 degrees. Make sure you know how to do that. Is everybody happy with that? Okay, so that means your reference angles are for between what and what?
The x-axis?
Yes. So that means this is 60 degrees and this is 60 degrees. So reference angle is 60. Okay. So the answer is, what is my rotation to get to there? 120 degrees. So I can say in quadrant 2, the rotation angle is 120. What is the rotation to go all the way to there? 240 degrees. Okay? So theta is equal to 120 and 240. Is that okay? No, the next question will show you. All this stuff will not be there. This is just setting you up on how to solve it, basically. But normally it'll just say, solve this. All right. Can I scroll down? Okay, so a little bit of notation before we get into this. Sine theta all squared, which means sine theta times sine theta, is written this way. They just put the square on the sign. They don't put it in brackets. Okay, so you need to be aware of that notation. So if you see sine squared theta is equal to 0.5, that means all of sine is being squared. It's the same as that. All right. Now, if I gave you this as a question, what would you do? You'd square root both sides, right? You do the same thing here. So I'm going to square root both sides. Now, when you square root something, what do you get? Positive and negative. So I get sine theta is equal, what's the square root of 0.5? Okay, so we'll use the decimal. 0.70 what? 71, thank you. And it's plus or minus. Okay, now it's like the one above it. We have a trig function equaling a number, except we have plus and minus. If we're positive and negative, what quadrants are we in? You're in all of them. So you're in all four quadrants.
So you don't have like two formulas, or just
No. The positive and negative tells you the quadrants. So the positive tells you these two, the negative tells you these two. All right, we need to find the reference angle. So you do sine to the minus 1 of the positive or the negative? Positive. It's always the positive. What's my reference angle? Hmm? So it's 45 degrees. 45 degrees is your reference angle. So that means that this is 45, this is 45, that's 45, and that's 45. So what does theta equal? If you start here to get there, with the first time is 45. That's the first quadrant. We got 45 degrees. If I keep going all the way to there, what do I get? 180 minus 45, which is 135. Keep going all the way to there. 225, whoever said that. And keep going all the way to there is 315. Those are all your answers. All right. Are we okay? Nope. Sometimes it'll be 2. This one's 4 because we had to square root it and we got positive or negative. So that tells us we're in all 4. All right. Okay, next one. Okay, so cotan is equal to root 3. Figure out what quadrant you're in. Cotan is what? 1 over tan. So we're essentially saying, where is tan positive? What quadrants? 1 and 3. Right? Add. Let me erase this and just leave it. Add sugar to coffee, or all students take calculus, whatever you want to remember. Okay, so we're in quadrants 1 and 3. Cotan is 1 over tan. I don't want to deal with cotan, so change it to 1 over tan. So 1 over tan x is equal to root 3. How do I solve for tan? Flip it. So I'm going to get tan of x is equal to 1 over root 3. Okay. I know what quadrants I'm in. I have a primary trig ratio, which is what you're trying to get. Now I have to solve for my reference angle. What is my reference angle? What is it? I don't know. You tell me. Is it? It's 30 degrees. So that means that's 30 and that's 30. So what does x equal? 30 and 210 degrees. That okay?
Wait, isn't it 6? You're starting from like. Aren't you like going like the whole length? So isn't it like starting like on the second part of the first quadrant?
Sorry, what?
Aren't you starting here? So wouldn't it be 60?
You always start. That's 0.
Okay.
So you always start there and then you rotate. Okay? Okay, next one. Do you want to do secant or cosecant? I don't care. We're only doing one.
Secant.
All right, that's what I heard first. What's secant? It's secant's 1 over cosine.
Yeah, it's stupid like that.
Okay, where is cosine negative? 2 and 3. Okay. So I got to solve for cosine, so I can just flip them and get cos x is equal to 1 over negative 1.2631. How do I find my reference angle? Yeah. So you do cos to the minus 1. Do I use the negative? No, just use the positive. Negative just tells you the quadrants. What is my reference angle? The negative will give you, it won't give you the right answer. It won't give you the reference angle. So you just use the positive to get the reference angle. 38 degrees. Or sorry, 38 degrees. There you go. If you just, okay, if you do cosine to the minus 1 of negative 1 over 1.2631, tell me what you get. You get 142, which is not a reference angle, right? So don't use the negative, only use the positive. It gives you one of the answers, but it doesn't give you the other one.
Are you allowed to have a decimal point for your degree?
Yeah, but they think they want us to do the nearest degree here.
Okay.
Yeah. All right, so 38 degrees is our reference angle. So those are both 38 degrees. So my rotation, x is equal to what? 142 is the first one to get to there. If I keep going, it's 180 plus 38, which is 218. So if you use the negative, it'll spit out this answer, but then it doesn't give you that because it's not a reference angle. So be careful with that. Okay, so if you have one of the reciprocal trig functions, rewrite it as its primary ratio and then do everything the same. Yes?
Okay, so I have like kind of 2 questions now. First, why do you use x instead of theta? Was that just because that's the
That's what they used here.
Okay. But it could be.
It's just, yeah.
second, would that be a decent way to check if your answer is correct? Just do like a negative one. If the negative one gives you one of your answers.
Yeah. Or you could just go in your calculator, do cosine of 142, and hit the reciprocal button, and you should get that. Sorry? X to the minus 1 or 1 over x. Or just go 1 divided by cosine of whatever the answer is. And you should get that back. Okay, 2 more, and then I'll give you some practice. Cos theta equals 0. All right. So, cosine theta equals 0. That gives us no information about the quadrants we're in because 0 is not positive or negative. So right away, find your reference angle. What's cosine of to the minus 1 of 0? It's 90 degrees. So where are you on the grid? What quadrants thingies are you in? Okay, you're here. There's a reference angle of 90, right? Where else? Yeah, you're right there. Those both give you reference angles of 90, correct? So, what's my rotation to get there? What's my rotation to get there? And if you want to check your answer, go cos of 90 and cos of 220 or 270. You should get 0.
Is that the same for tan?
It makes more sense when we see the graphs later on, but for right now, you just have to trust me. So you won't trust me. All right. Cosecant theta is undefined. So why do the reciprocal trig functions have undefined points? Why does anything have an undefined point? You're dividing by 0, right? Can you do this? If I gave you that, what's the domain restriction? What can x not be? X cannot be 0, right? If it does equal 0, it's undefined. So because cosecant is 1 over sine, there's a domain restriction because if I put an angle in that makes the bottom 0, you're dividing by 0. So these graphs, we'll see these graphs later on, actually have vertical asymptotes on them. I know, something to look forward to. All right. So we're going to say 1 over sine is equal to undefined. What makes something undefined? We just talked about it. You're dividing by 0. So what that really means is that it equals something over 0. Boom. There you go. Therefore, sine theta has to equal 0 if the answer is undefined. 0 is neither positive or negative, like we just learned in the first one. So what do I do right away? Find your reference angle. Is 0. There's a lot of zeros here. This makes more sense when we learn the graphs and you can see a visual of this. But we haven't learned the graphs yet, so we learn them in a few days. So we get sine to the minus 1, the reference angle is 0. Okay. If my reference angle is 0, where am I? So I'm here. Where else? The other side. Here? Okay. Anywhere else? No? So you mean if I went all the way around?
Yeah.
Yes. It is, but watch. Okay, so what does theta equal? To get to this bit right here, I go 0 degrees. Okay. To get to this bit right here, where do I go? 180. To get to the next bit, where do I go?
360.
Now, it's very important. This is why this matters. you got to look at your domain restriction. What does that little line there mean?
Greater.
Less than or equal to. If it was this, now I won't do this on a test, but on all provincial exams they would do this. If I wrote theta is less than 360 but greater than 0, what is my only answer? 180. So the domain restrictions matter. Okay? On a test, I'm not going to give you something that's subtle because I think that's just a whatever. Not a nice thing to do. But just be aware that domain restrictions matter. You always have to look at this. We're going to see some in the next little bit after I give you some questions where it's more obvious, but just be aware of that. You always look at the domain restrictions. So we got 3 answers, 0, 180, and 360. The positive or negative sign tells you what quadrant you're in. Like this. Tells you the quadrants. Find the reference angle. Map it out, and then just figure out what your rotation angles are. Any questions?
What questions are we doing?
We are doing number 1, number 2. That's it? Just number 1? Number 1 we're doing, okay, pick 2 from number 1. Pick 2. Number 2, I want you to do A and D. And number 3, do them both. All right. Pick 2 from number 1. Number 2, do A and D. And then question 3 only has 2 questions. So. All right. So if your domain is in rads, your answer has to be in rads. Okay? But that doesn't mean you have to do the whole question in rads. Okay? If you want to do it all in rads, be my guest. I recommend that you do it all in degrees, convert to radians at the end. Okay? So, for example, cos theta is equal to negative 0.5. This is one of the ones we did right at the beginning. Where is cosine negative? 2 and 3. Boom, boom. Find your reference angle. Remember, we don't use the negative. What is the reference angle? 60 degrees. So that means this is 60 and this is 60. So theta in degrees right now is going to be what and what? Okay. Now, we do not have, you're not going to get full marks for this right now. To get full marks, you have to have the answer in rads. If this is out of, say, 3 marks, you'll get 2 out of 3. Yeah?
Why do you want rads?
Because the domain's in rads. All right? So if the domain is in rads, you got to give me your answer in rads. What? I don't even know what you're saying right now. So, how do you change this to rads? There's 2 ways to do this. One, you can know the common ratios. So, what is 60 degrees in rads? Pi over 3. How many 60-degree angles are in 120? 2. So this would be 2 pi over 3. How many 60-degree angles are in 240? 4. So it'd be 4 pi over 3. You could do that. Or, if you don't like that and you prefer the decimals, multiply by pi over 180, right? If you go 120 times pi divided by 180, the decimals are 2.094 and 4.189. Those are the same thing. I don't care what you give me on a test. If I say give me the answer in rads, as long as it's one of these, or like written either way like this, that's fine. You'll get full marks. If it's written like this, you're not going to get full marks. Okay? So make sure you know how to convert to radians. No. I know.
I think they're measuring things right now.
We're the same level.
Measurement's capital.
Yeah.
Same thing. Oh, it's Azteca.
Yeah.
Do you say that now to Azteca?
That's what they asked me. Why it's called the cast rule, not the Azteca rule.
It's Azteca. Starts in 1.
I know. All right. Second one. Cotan theta is equal to negative 5 over 4. What does the domain say?
You have to be equal to 0 or
It has to be less than 6.2.
6 point what? Okay. First of all, is the domain in degrees or rads? It's in rads, so our answer has to be. Now, what's cotan? Let's start with that.
1 over 10.
It's 1 over 10. So tan theta should be the reciprocal of that, right? Negative 4 over 5? Does that make sense? Okay, what quadrants is tan negative?
2 and 4.
2 and 4. Okay. 2 and 4. Do I use both of those? What's my domain restriction? 180. Remember, pi is 180 degrees. So this one, you ignore. Because outside it's outside of the domain. All right? So you have to look at the domain restrictions. Now we just need to find our reference angle. What's our reference angle? I don't actually know. Sorry, what'd you get? 143? Don't use the negative, right? Tan to the minus 1 to 4 over 5. Don't use the negative. What's my reference angle? 38.7. Let me check. 38.6. Yeah. 6. I guess I should be. They say to the nearest 100, so let's actually follow it. So that's going to round to 6.6. There we go. 38.66 degrees. So that means that. Come on. There we go. This angle right here is 38.66 degrees. So what is my answer? What is theta? Yeah, it's going to be 180 minus 38.66, which is, what'd you say? 180. 141 point, not 1.41. 141.34 degrees. Is that my final answer?
No.
What do I have to do? Convert to rads. How do you convert to rads, especially if it's an ugly one like this? Pi over 180 is 2.47. Something close to that. Is that right? All right. 2.47 is your answer. And the only answer because of the domain restriction. All right? Watch the domain restriction. If the domain is in radians, your final answer has to be, but you don't have to do all the work in rads if you don't want to.
So, in terms of practical application of rad, it's simply just it's another way of putting the answer in.
It's another way of writing the angle. Yeah.
Okay, so like would there, right? So it's not like you would use one for this situation and one for this situation. It's just.
Well, yeah. There's other ways of writing angles too, but we're not going to worry about those.
Like writing it in rads versus degrees is like if you try to put your number in scientific notation versus writing it. It's just.
Essentially, yeah.
It's essentially.
All right. Here's what you're doing. Number 4, C and D. Number 5, F. And number 6, B. Obviously, if you need more practice, do them all. But that's it for today. Finish those questions, and tomorrow we will move on. What are we doing tomorrow? Hang on. Well, let's have a look. Let me stop this video first. 1 sec. Yes.